this is sort of what happens. I thought this was cuter than what your book had. Okay? I don't know, it just looked like little gremlins or something. Now, do you notice any type of terms or information in this picture that make you question anything? Huh?
Yeah.
Okay. So I didn't hit that yet.
No
The
cytokines. I didn't explain that yet either. Good deal. Okay, so there are basically 3 stages that are recognized. We recognize that there is a stage of recognition, that there is a pathogenic cell in my body. And then we're going to have the stage of attack, and we're going to have a stage that creates the memory. Now, your textbook, if it's still up, the site doesn't normally like to stay up, shows you this. Okay? So here's what's going to happen. I'm going to have the antigen presenting cell, that monocyte, that's going to be picking up some of that foreign pathogen. And when that happens, we're going to see that hopefully that antigen gets recognized by a cytotoxic T cell or a helper T cell. So the goal is that the T cell will bind to the antigen that's getting displayed by my antigen presenting cell. Does everybody see that? So my antigen presenting cell picked something up, put a little piece of it on its membrane. The T cell is hopefully going to recognize that and now mount the attack. So the T cell hopefully binds to that protein on the antigen presenting cell. When that happens, the first thing that we need to do, I need to clone some cells. Meaning, that T cell that made the recognition, I need to, if it was the TC or the TH, depending on which one it was, if it was the TC, the cytotoxic, I need to make more of the exact same cell that now recognizes the foreign piece on the antigen presenting cell. Does that make sense?
Wait, so does it do all of them, or is it just choose?
It depends on what it's attacking. Does it need to attack something that we've got to lyse the cell, or do we need something that's going to become a helper for fighting and making antibodies? Okay? So
how would you make more of those?
how do you make more of what?
Of the T, when you said you would need
The T cell duplicates itself.
so automatically will
It'll
make
automatically start proliferating.
That's why the mitosis is there, because it.
Yes,
Okay.
because that T cell is now going to start making copy after copy after copy after copy that will recognize the foreign pathogen. Okay? And in cloning itself, it's going to generate a few that are going to, their only job, recognize the pathogen and go sit and wait. Become the memory cells. That's it. They don't have to go do anything else except go sit now and wait for the next time there's an exposure. Now, the cells that got replicated, I should say, to go fight, all right? Here's what they're going to do. They're going to recognize the enemy cell, and they're going to begin to destroy it.
Is that also the killer cell? It says killer cell right here.
Where?
Or T cell. No, on the other diagram.
Which diagram?
The one
What
you
she gave us.
The one you gave us.
Oh, okay. One of the cells that it can activate is a natural killer cell. You just got ahead of me a little bit.
Oh, sorry.
Okay. So the goal: take the T cells and destroy the enemy cell. Because this is cell mediated, it can activate natural killer cells, B cells, T cells. Does that make sense? Just like I mentioned in the slide, the previous slide.
Say that again, because it was cell.
Because it is cell mediated,
That's
I
right.
have not produced any antibodies. The only thing I have produced are fighting cells. That's it. Now, the little cytokines, also known as interleukins. Okay. Well, this is simply the production of those chemicals, those interleukins, cytokines, they're called interleukins, okay? This is the chemical that is produced that is going to allow the communication between the monocyte, between basically the T cell and the monocyte to occur. It lets them talk to each other. That's what cytokines, also known as interleukins, they let the cells talk to each other. And they're also, they're going to be able to say, we've got to have this production. There is a pathogen present. At this point, the only thing that we've dealt with are cells.
Well, why would interleukins be secreted if the enemy cell is destroyed?
They need to be alerting the cells around them that there is a pathogen present.
Even if it's already destroyed?
But no, once destruction is done, they'll stop talking to each other.
Okay, so that happens while the
there's-
T cells are trying to kill it.
Yeah, while they're getting presented with the pathogen and all the processes that got to occur, it's allowing the cells to talk to each other to, hey, let's make more cells to go fight the antigen.
Okay.
Is that because the memory T cells don't actually do the destruction themselves?
Memory cells do not do the destruction
So
themselves.
the interleukin is like once they
It can communicate with them, but once the memory cell gets produced, it just needs to go. I mean, they don't fight. Yeah, they just go sit.
They
and
don't
wait.
fight, they just let them know when something's here.
No, once
They
the
let
T
them
cell
know.
is created, they basically just go and sit and they'll just migrate all to different lymph nodes. They don't fight. They
So-
don't do
So
anything.
when it's created and let's say a year later you have the same foreign antigen that comes in, do they fight it or they just make it aware that?
It's
They
that
will
specific
then
thing.
become the recognition cell that will have to start proliferating, and in their proliferation, more T cells, more memory cells will get created.
Okay.
Yeah, they're not the first time. They're not fighters. They're waiters.
Can memory cells be passed down from like the mother to child?
There is different immunity that is passed from mom to child. It only lasts for a few, I think about 3 to 6 weeks of life. Okay, So it's not necessarily a memory that's being created in the child. It's an immunity that's being passed from mother to child, and then we're dependent on the child's immune system kicking in and making its own memory cells. So, cell-mediated. Cells. The next one, humoral, not ha-ha, okay, but in the fluids. It's definitely more indirect than the cellular immunity. We are now going to see that the B lymphocytes, B cells, everybody hear that? The B, okay, produce antibodies that can bind to an antigen and then tag them for destruction. We have plasma cells that are going to develop from the B cells, and this process requires T helper cells, the THs. The only antigen presenting is a B cell. It deals with that protein complex 2. The chemicals that'll be used are antibodies and complements. The mechanisms: cytolysis, phagocytosis, immune clearance, inflammation, neutralization, agglutination, precipitation. Whoa. Memory is secondary. This means that the memory that gets created, it's with B cells. These are located in the cortex, the outer portion of the lymph node, and when it mounts, like the next time you get exposed, it is so quick that it's nothing for you. No signs, no symptoms, no anything. Lucy?
Going back to the helper T cells and the cytotoxic T cells, are cytotoxic T cells, they're
Cell mediated.
but they're good. They're good. Like they kill other cells. They're not
Yeah.
toxic to us. Because you said they are toxic to cells.
They will kill the pathogen, and if we have a cell of our body that has become a host, it will destroy that cell.
Okay.
Yeah. Other than that, it should not attack cells of our body.
But if you have an if you have an autoimmune disease, that's what's attacking you.
That's what's going to happen.
Gotcha. Okay.
Yeah, that's what's going to happen. So I tried to get this picture, this PowerPoint slide, to turn in the portrait formation, but you can only do a PowerPoint presentation in one or the other. You can't do it in both. So that's why I gave you a handout. It's actually the handout from the textbook. And now the difference between cell-mediated versus humoral. All right, let's look at it. If we have our antigen that they're representing with the little dot, okay, that is the pathogen that is in the body. Note that for my lymphocyte, I've got little receptors that are present. Now, that is an antigen recognition piece. It is to help recognize that antigen. These B cells are immunocompetent, meaning they have the ability to attack that pathogen. So those B cells that get exposed to that antigen, it can bind to the receptors. This B cell has now recognized the antigen, and it now needs to fight the antigen. What does it need to do? Well, because it has recognized the antigen, that B cell internalized it, meaning that antigen attached to the receptor, that B cell basically enfolded on itself, consumed the antigen, and put a piece of it on its membrane. So, it is now showing the little piece that it ingested. And it is now asking for the T cells to help. So this is my TH. Remember how I said it depended? The TH or the TC? Okay. This is my helper T cell. Now that this B cell has recognized the antigen, basically we're going to find that when the helper T cell binds to it, it secretes interleukins, which are ways to talk to the other cells. The B cell that has now recognized the antigen needs to divide. We need to make more copies so that they can recognize the antigens, have the receptors come, attach, and bring that antigen into the B cell for destruction. So my B cells duplicate. When I look at what's going to happen with those B cells, those cells, some of them become my memory. The rest of them have to go on, and what they become is termed a plasma cell. The reason for that, we need this cell to make the receptors, basically the antibodies. So we basically have those B cells differentiate into what we call plasma cells, which will produce these antibodies, which are going to be the receptors that will attach to lymphocytes that will eat the antigen. And the way that they make their way to the B cells is they flow through the blood, well, the fluids of the body.
Wait, what makes their way to the B cells?
The antibodies, the receptors. Because the receptors can attach to cells, and the cells will take in the antigen and destroy it.
So the plasma cells make the receptors,
Yes,
which is
the
then-
antibody.
okay.
Mhm.
At the top, it looks like the antigens are just free floating, but would they be attached to a cell when they would?
They would be free floating so that those antibodies could pick them up, and then white cells could come along, engulf them, and destroy them.
well, I'm talking at the very beginning. Well, when we've talked about antigens in the past, it's been like a macrophage or something has like consumed it and then presented it as part of the antigen for the cell mediated. But for this, like,
This time it's just a B cell.
I get that. I'm just, why would there just be like an antigen attached to the cell just floating around?
This could be an allergy.
Oh,
This
okay,
could,
yeah.
it's gonna be, what is it that it's getting, that it's recognizing, okay? The ones that are for the cell mediated, a lot of times that's gonna act against viruses. It'll act against bacteria, but we're invaded by lots of other things too, like the little allergens, toxins, other stuff that's gonna just float around in the fluids.
And could another pathogen that was lice have like free floating antigens afterwards that it uses to do this? Or
Now, a cell that's lysed, when? This is not cell lysing. This doesn't break up a cell. The only thing it does is produce these little antibodies to pick up the pieces.
So does humoral mediation always requires, like, cell-mediated response can act on its own without the B cells, right? But the B cell has to have the cell-mediated response in order to respond.
No.
So where does the helper T cell?
No. Cell mediated is just that. Okay? The humoral is just this.
So they act.
In cell mediated, your end product is going to be a cell that will destroy a cell. In humoral, your end product is this antibody that will attach to an antigen and wait for destruction from another white blood cell.
Okay.
Yeah. Okay? If you do the comparison between the two pictures, okay, look at the comparison between the two pictures, you'll definitely see the differences and why they're named what they're named.
So when you say a T cell, well, obviously I know what a helper T cell, but when you just say a T cell, does that mean cytotoxin?
We have the cytotoxic and the helper.
Okay, got it.
Yeah, and think about it. Cytotoxic, killing cell. So that would stand to reason that that's very prevalent in the cell mediated. The T helper cell is the one needed for B cells because it'll help stimulate that reproduction, that differentiation in plasma cells.
Okay, got
So
it.
the T helper cell is needed for humoral.
Okay.
Does that make sense?
Yes.
But, okay. Do you mind going back to the other picture really quickly?
Oh, the one.
I don't know why, like,
So note, they're letting us know that this is the full T cell. This is my antigen presenting. The T cell recognizes it because this one is now cell mediated. I'm going to produce more T cells. I'm going to produce the ones that will become a memory. These T cells that have been created, they will go and attach to the enemy, and they can kill it by way of they can kill it with the activity of like a natural killer cell. A lot of times, that's what's happening. They're perforating the cell. They're injecting the granzymes, and this entire cell, which is the pathogen, is going to die. It's just going to burst. Okay? Now, the other one, which is not going to let me go to from the book, this one, there's an antigen that got into the body. B cells with just some receptors, not really, doing anything, that antigen attaches to it. For this B cell to duplicate, I need a helper T cell to come along and help it. And when it duplicates, some of it needs to go to memory, meaning that this B cell is going to already have receptors on it, so anytime we get it exposed to that antigen again, it'll pick it up. Now, the differentiation, the cloning of the B cells, the one thing that's going to happen, they turn into what's called plasma cells, because their job, rather than be the cell that attacks the antigen, be the cell that produces the receptor, the antibody that'll kick it up.
So in the humoral, the B cells is what gets makes more of it, and then the mediated is where the T cells make more.
T cells do not make anything.
B cells are the ones that
make more of itself, expand, get more.
The T cell will help that B cell proliferate in the humoral. Okay, that's it. That's all the T cell's going to do.
we just have to
in
think of it
humoral.
as the T cells as a helper. It doesn't do anything.
It's just a helper. And cell mediated, yes, T cells duplicate and attack.
Oh, okay.
But the T cells, I think what I got confused about, the T cells exist on their own.
So the T cells actually.
So
And
do
then,
B
like,
cells.
in the different responses,
T cells,
the T cells are used in different fashions. That's what I'm saying. Because I was confused and thought helper T cells were created as by virtue of the cell-mediated response. So that's why I'm asking, do they
Like,
have to-
take that the T helper is only being
I see.
humoral,
Characteristics.
and then the cytotoxic T cell, the one that will attack and destroy.
Okay.
That
There's
makes sense.
there's a little thing in the book. There's a table on chapter
Yes.
in 836, and it tells you like it's just the characteristics of the cellular immunity and
Yes.
humoral immunity.
It's like right there at the bottom of the page.
Yeah.
Yeah. Okay, let's use what little bit of time we have left for those